So earlier we talked about logical equivalence and with things such as standard statements. Well, what if now instead we have two statements and we want to check them via truth table? This can be done. First, we do have to convert this into P's and Q's, or R's if you will, whatever your favorite letters are. What I will say in this case, let's call dogs bark and cats meow. Let's say dogs bark is P, and so that's our, there we go, and cats meow, we'll call that Q. And then if cats meow and dogs bark, we'll have Q and P. So first thing is always, let's start by filling in our truth table, P, Q, and we want to check does long term is P and Q logically equivalent to Q and P. Recall that this is the symbol for logically equivalent. This also comes from congruence. If you're familiar with geometry, they use a symbol for congruence, but logically equivalent, we do add an extra constraint as far as just having an equal sign. So the other two columns we will need here are P and Q and P. For time, I will go ahead and fill this chart in. Notice here that we're still working with all the same things we've been talking about this evening. And one thing I'd like to highlight is that once we've filled in our chart, if we're checking for logical equivalence, these two columns should have the exact same outcome. So if we look more closely, we have true, true, false, 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 and finally false, false. Because of this, we can officially state that these two statements are logically equivalent, which allows us to, again, use our symbol to describe them. In addition to this, we can also have, or try and show things that are not logically equivalent. For example here, if we want to show that not P and Q is not logically equivalent to not P and not Q, let's verify what all of those look like. We're going to need P, Q, not P, not Q, and then we will need P and Q, and we'll also need not P and Q. And lastly, we can combine our not P and not Q. So I'm going to get us started off here and fill this in. To finalize here, if we look at not P and Q, we reverse all of the true-false statements that we had in the previous column. Then we have not P and not Q. So compare those. The only one that's going to be true will be this last column here. And the rest of them are going to be false. Now if we look closely, false, false gives us false, false, true, false, and so on and so on. These definitely take some practice to show. However, to finalize why they're not logically equivalent, let's take a final look here. So in comparing these two things, we make note that, well, yeah, they have these two in common, but what do they not have in common? Basically everything else. They have none of those in common, and therefore we can say this is not logically equivalent. One note I would definitely like to add here is that when you're working with these statements, sometimes it takes a little bit of playing around. Remember when we talked about order of operations? We'll note our parentheses here. Because of these parentheses, that means we'll first have to find P and Q before we have our not of that. And same thing over here, since we have two nots with a conjunction, that indicates that we have to find not P, not Q first, and then we can combine them. So again, definitely work on some of the homeworks for these. Keep practicing with them, because the more you do, the easier they will get. So with our logic rules and such, we definitely have a lot of rules coming up. One of the most important that we work with is called De Morgan's laws, and these are negation rules. So if you recall earlier, we'd seen something that looks sort of like one of these, wasn't it? That was kind of a sneak preview in a way. if we are taking a conjunction and we want to negate an entire conjunction, that turns into, again, note the symbol for logically equivalent, not P, disjunction, not Q. And basically what happens here is we take both of our variables, we negate the variables, and then we flip the sign. So we go from conjunction to disjunction or disjunction to conjunction depending on. So let's look at an example or two. Write the negation of the following statements. John is 6 feet tall and he weighs at least 200 pounds. Well, if we want to negate this entire statement, so think of it this way, well, that would start off by John is not 6 feet tall, and so John is not 6 feet tall, and opposite of our conjunction would be an or our disjunction. So he's not 6 feet tall, or he does not weigh at least 200 pounds. Now, one thing to note here, again, is that there are several ways you could rewrite these depending on how you prefer to approach the English language. To negate the at least, you could say something along the lines of, I don't know, at most, or something of that sort. Basically, anything that's opposite of the at least. Now, a trickier example we could have is something like this one here. -1 less than x less than or equal to 4. Now, if we break this down like we did earlier this evening, this means -1 is less than x and x is less than or equal to 4. To negate this whole statement, that would mean that -1 is not less than x, or x is not less than or equal to 4. From here, you could really leave it as is. There's lots of things you could do with it. You could flip sign here, or this or that, but this would be perfectly acceptable, how we have it. A few other vocabulary words that are going to come in handy are tautology and contradiction. Now, a tautology is something that is always true regardless of what it is. For example, saying that x, or now let's go with something more like 1 is less than 7. This would be considered a tautology because it is always true regardless of any other whatever's come into play here. So again, something that's always true. Along with this, a contradiction, something that's always false. An example of this would be saying 1 is greater than 7, because this can never be true. It's always going to be a false statement. Let's kind of try and visualize this using a truth table here. So I'm going to start by filling us in, and we will be back momentarily. Notice that the filled in truth table here, we have an entire column of truths. What this means is that we have a tautology, and then to the right here, notice we have all falses. This would be a contradiction. These are just, again, other ways we can visualize some of our vocabulary with our truth tables. And this stuff does come up from time to time. Especially one thing that I would recommend looking at is page 35 in the textbook has a really nice chart to organize this information. So definitely if you have that with you, I would recommend glancing at it at this time.